In this session, we'll continue to look at solutions to CSEC Advanced Past Paper questions. Specifically, we'll be looking at a question from paper 2 of 2023, and this question is on from section 4, which deals with probability and statistics. So this is question 6 from section 4. It's on probability and statistics. So let's look at the question. The following stem and leaf diagram represents the scores out of 80 of students in an additional mathematics exam. So here we have a stem and leaf diagram. We can clearly see the stem, which of course is the main part of the scores, and these are represented by the digits 3, 4, 5, 6, 7, right? So those numbers in that column represent the stem, and of course these scores over here represent the leaf, and together these scores, for instance, these ones would be 30, 33, 37. Similarly, these ones would be 42, 44, 46, 47, 49. The third set would be 51, 53, 53, and 56. The next set would be 60, 77, and 77 once more. And the last set of scores would be 71 and 79. So this stem and leaf diagram basically is a more concise way of representing these scores, right? So these are the scores of this particular test. And of course, the maximum score would have been 80. Now, part A of the question says, write the raw data set that was used to construct the diagram above. And essentially, we've just done that. We've written them out 30, 33, 37, 42, 44, 46, 47, 49, 51, 53, 53, 56, 60, 7. All right, so see a little mistake here. So, right, so these should not be 77 because you haven't reached the stem of 7 as yet, but you're still on 6. So these should be 67 rather, and 67 again. Right, so glad I fixed that little mistake there. Right, so these are the scores 30, 33, 37, 42, 44, 46, 47, 49, 51, 53, 53, 56, 60, 67, 67, and lastly we have 71 and 79. Right, so these are the scores that would have been obtained in this particular test. Now, 2 marks for that. Now, the next part of the question says, determine the following measures for the data set, the median score. Now, what is a median? The median of a set of scores is the one that occurs in the middle. And of course, for us to determine the median, the scores must be written in order. They can be written in either ascending order or descending order, but they must be written in order. If the scores are just random, then of course we will not be able to accurately determine the median. And so if we're given a set of raw scores and we wish to determine the median, the first thing that we should do is to actually arrange the scores either in ascending order or descending order. Now, fortunately for us, these scores were essentially already arranged in a particular order because we can see that we started off with the lowest stem and we went up to the highest stem. And of course, in terms of the leaves, then of course, these were also written in order from the smallest to the largest. So 33, 33, 37, and so on, 51, 53, 53, 56. And so let's count the number of scores. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So in total, there are 17 scores. And the good thing about it is that 17 is an odd number, and it therefore means that we will be able to determine the median, which of course will be a single score. Now, because the scores are already written in order, then we can simply locate the 9th score. So if we have 17 scores in total, then the median will be the 9th score. We have 1 to 8 over on this side, and then of course we have 10 to 17 over on this side, right? And so this we have 8 scores over here. We have 8 scores to the right, and of course the median in the middle, okay? So if we look at the numbers carefully, again, let's count. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. The 9th score is 51, and that, of course, will be the median. So the median of all these scores, these 17 scores, is the 9 score 51, right? So the median exam score is equal to 51. Let's put that down here. So B, part 1, the median score is equal to 51. All right. Now let's look at the mean. Now part 2, they want us to calculate the mean, right? The mean. So part 2, they want us to find the mean. Now, how do we calculate the mean? Whenever we have a number of scores and we want to find the mean is the sum of all the scores. So we can write that out as a mean as the sum of all scores divided by the total number of scores. And this is, of course, how we calculate the mean. In some cases where we see that there is, say, there are repeated scores, you may see a formula looking like this. Mean is equal to sigma fx over sigma f, where f, of course, represents the frequency, and x is a particular score. So, for instance, if we have a particular score, say twice, we would multiply that score by the number, and of course, we proceed to adding those, right? Now, if we examine the table of scores, or the scores that are shown here, then what we'll be able to recognize is that we have certain scores which are listed more than once. So we can go ahead and calculate our mean. So let's do that. So in terms of calculating the mean, we would say that the mean equals, so we have 30 plus 33 plus 37, right? Plus 42 plus 44 plus 46 plus 47 plus 49, right? And we continue. So 49, and then we have plus 51, then we have plus 53. Now 53 is actually listed twice, but since we can just, it's only 2 times, so we could just write it down. So plus 53 once more, and then of course we have plus 56, then of course we have 60, then we have 67 twice, so plus 67, plus 67, and our last 2 scores, plus 71, plus 79. So that is the sum of the scores. So let's just work out the sum of all the scores first. So the sum of all scores is equal to that, and we go to our calculator. Let's see what this is going to give us. So we have 30 plus 33 plus 37 plus 42 plus 44 plus 46 plus 47 plus 49 plus 51 plus 53 twice plus 56 plus 60 plus 67 twice plus 71 plus 79, right? And the sum of all scores, this gives us 85. So the sum of all this, 885. So the sum of all the scores is equal to 885. And of course, by simply counting the number of scores, we see that the sum of f, or sigma f, is equal to 17, right? And therefore we can say that the mean, so the mean is equal to 885 divided by 17. And what does that give us? So divided by 17. So that gives us approximately 52.06. But we can actually express that to the nearest whole number, which is approximately 52. If they want the answer correct to say, for instance, a certain number of significance, let's say 3 significant figures, then this would be 52.1 correct to 3 significant figures. But of course, each score was represented as a whole number, and so the option might have been to actually express the mean as the nearest whole number, which in that case it would be 52. So the mean score is actually 52. All right. Now, let's talk about the modal score. The next part basically asks us to determine the modal score. Now, what is a mode of a set of data? The mode is the score or the value which occurs most often or most frequently. Now, let's look back at our stem and leaf diagram to try and identify the mode. Now, at each level, we see that in first, we have only one of each score, 30, 33, 37. In the next level, we have only one of each score, 42, 44, 46, 47, 49. But on this level, we have two scores, or two of the same scores, which of course, 53, 53. So 53 occurs twice. In the next level, we also see that there is a particular score which occurs twice, and that score is 67. On the next level, each score only occurs once. So basically, the two scores which occurs more than once are 53 and 67, and they each occur twice. And so therefore, what this means is that the modal scores would be 53 and 67. And that explains the presence of the S in brackets, because we'd have expected to actually get two values or two scores for the mode, 53 and 67, right? Now, part 4 of the question. Part 4 of the question says, given that the data set sigma x squared, or for the data set rather, sigma x squared, and once again, the Greek letter sigma is used to represent the sum of in math, all right, and in physics too. So we say that sigma x squared is equal to 48,999. And what this represents is the sum of the squares of all scores. So if we look back at our stem and leaf diagram, we had 17 scores. If we want to determine sigma x squared, we'd have to square each score, then add up all of those squares, and that would give us sigma x squared. But that has been done for us, and so we have that sigma x squared is equal to 48,999 or 48,999. We're also given sigma x, which of course we worked out earlier, to be equal to 885. And we're told to find the standard deviation using the formula S is equal to the square root of sigma x squared minus sigma x all squared, and that is over n, and the entire thing is over n minus 1. So this basically requires us to substitute the values into the formula and find the standard deviation S of the data set. So let's proceed to doing that, right? So if we put these values into a formula, we get that S is equal to, I'll leave out the square root sign for now. So it's sigma x squared, which is 48,999 minus sigma x squared. So this is 885 squared over n, which is 17. And of course, all of this is over n minus 1. Now, n is equal to 17, and therefore n minus 1 would be 17 minus 1, which of course is 16. So this, of course, is the s squared, but of course, let's put our square root sign, and so this gives us, right, all of that. So all of that is supposed to give us the standard deviation S of this sample. So let's once again we go to our calculators. So we see that 48,999 minus bracket 885 squared divided by 17, close that bracket, equal, then we divide that by 16, which gives us 182.93. So this gives us a square root of 182.93, which of course gives us, so we go square root, answer, that's about 13.5, right, so approximately 13.5. So the standard deviation is approximately 13.5, which of course we can approximate to being 14 if we're expressing it to the nearest whole number, right? So the standard deviation of these scores, 13.5 corrected three significant figures, or 14 as expressed to the nearest whole number, right? So that would be the answer for part 4. Standard deviation S is equal to 13.5 is approximately 14. Part C. If a student needed to score at least half the total marks possible to pass the exam, determine the probability of a student failing the exam. Let me read this question, let's part of the question again. If a student needed to score at least half the total marks possible to pass the exam, determine the probability rather of a student failing the exam. Now, what is the total possible mark as indicated? If I remember correctly, the total possible mark is 80. And now, of course, I'll just scroll back to verify that. So total possible mark is equal to 80, right? So let me just scroll back to check. Yes, it says out of 80, right? So the total possible mark is 80. And of course, half of that, so half of 80 is simply equal to 80 divided by 2, which is equal to 40. And so basically, according to this information, a student needs to score at least 40 in order to pass. And they therefore ask us, what is the probability of a student failing the exam? Now, how do we calculate this? Now, at the simplest, to calculate the probability of a student failing, we're going to say that the probability P of F, let P of F be the probability of a student failing. Then this is basically going to be equal to the number of students who failed divided by the total number of students. So I'll repeat that. The probability for student failing would be equal to the number of students who failed divided by the total number of students who actually sat this exam. And we'll go look back at our stem and leaf diagram to identify the number of students who failed. And of course, we know the number of students who sat the exam because we know it's 17 scores. All right. Now, remember that in order to pass, a student must score at least 40. And therefore, failure means a mark which is below 40. Now, if you look at our stem and leaf diagram, we see that basically the first stem is 3, and it means that all scores with that particular stem would represent failing scores, of which there are 3 of those. Okay? So therefore, the number of failing scores is equal to 3. And this means that 3 students would have failed the exam. And so therefore, the probability of a student failing would be equal to 3 divided by 17, which represents the total number of students. And so we say that 3 divided by 17, approximately 0.1765, but we're asked to give it to 2 decimal places. So this is approximately 0.18 correct to 2 decimal places. All right. So this right here would represent the probability of a student failing, given that the pass mark, of course, is 40. All right. Now, part D of the question says, given that a randomly selected student has passed the exam, what is the probability that the student scored over 60? And give your answer to 2 decimal places. Now, let's read this question properly and let's focus on what exactly is being asked. It says, given that a randomly selected student has passed the exam, what is the probability that the student scored over 60? Now, this represents what we call a conditional probability, where you want to find the probability of an event occurring, provided that some other event has occurred. Let me repeat that. When we are asked or tasked to find or to evaluate a conditional probability, it basically means that we want to find the probability of an event occurring given that some other event has occurred, right? So this event occurring is conditional on that other event occurring. And in this particular case, our 2 events are student scoring over 60, right? That's one event. And the other event is, of course, that the student passed the exam. Now, I did not mention these in any particular order, right? So the student has passed the exam, and this, of course, means that the score is greater than or equal to 40. So we want to find the probability that the student scored over 60, given that the student, let me repeat it. We want to find the probability that the student has scored over 60, given that the student has passed, right? Which of course makes sense, right? So the probability that the student scored over 60, given that the student has passed. So let me define this event by the letter S for 60, all right? Scoring over 60. And let's define this event as P for passing. And so having defined those events, what we want to evaluate is the probability or P of S given P. That is how we express that conditional probability. So we want to find the probability that a student scores over 60 given that the student has passed. And so we typically represent this as P of S intersect or and P over P of P, right? So when we are evaluating a conditional probability, it's like our sample space has now been reduced to represent the condition that we're actually given. And this condition, of course, is that a student has passed the course. And so essentially for this part, our sample space becomes the number of students who actually have passed the course. And so we can further go on to express this probability to be equal to the number of students who score over 60 and of course pass the course divided by the number of students who pass the course. And we can get these numbers by going back and taking a look at our stem and leaf diagram, right? Now bear in mind it says number of students, or what is the probability that students scored over 60. Over 60 implies greater than 60, which means 60 is not included. So you must pay attention to that. So over 60 means 6 to 1 and above. Not 60 and above, but 6 to 1 and above. So let's go and look at the table to see how many students scored over 60. So look at these scores and look at the stem and leaf diagram, right? Up to this particular point is where the student scored up to 60, up to this point. So we'll basically exclude these. And so therefore, there are 4 scores that are over 60. And these, of course, are 67, 67, 71, and 79, right? So it means that 4 students would have scored over 60, and therefore n of s would be equal to 4. Now, how many students have passed? Now, we already established that 3 students failed from a previous part of the question, and therefore 3 from 17 leaves 14. And therefore, the number of students who have passed is equal to 14. So having determined those numbers, we can go back and calculate the probability. And so what we'll get is this. The probability of a student scoring over 60, given that the student has passed, is equal to 4 divided by 14. And we express this to 2 decimal places. Let me see that. 4 divided by 14 is 0.29, right? So 0.29. So what this means is that there is a 29% chance that a student has scored over 60, given that the student has passed the exam. In other words, approximately 29% of the students who passed the exam have scored over 60, right? That is another way of representing that information there. All right. Now, the next part of the question basically wants us to describe, or based on the given stem and leaf diagram, describe the distribution of the data set. Now, unlike the previous part of the question, which required a quantitative or a numerical answer, this one doesn't. It requires an explanation of our description, a description. And the responses to this type of question might be somewhat subjective, right? So let's look back at our data and to see how well we can actually describe the distribution, right? So what can we say about this? So let's first of all like examine how many students fall within a particular interval. So we basically see that 3 students Three students scored in the 30s. So it means that three students failed the test or failed the exam. The next step, we have 5 students scoring between 40 and 49. And of course, we have 4 students scoring between 51 and 56. Similarly, we have 3 students scoring between 60 and 67. And we have 2 students scoring over 70. So earlier, we calculated the mean, and we found the mean to be was approximately 52. So this distribution also shows that approximately, let me see, about, 4 students will be scoring in the 50s, right? So in terms of actual percentages, the 3 students who scored or who failed rather, they represent approximately, let me see what percentage that is. 3 divided by 17, did I already write that out? Approximately 18 or 17.6% of the total number of students. The 5 rather, who scored in the 40s, that's 5 divided by 17. That's approximately 29.4%. For those who actually in the 50s, that's 1, 2, 3, 4, again divided by 17. That's approximately 23.5%, and so on, right? Now, in terms of the describing the what I asked us to do again, I forgot to describe the distribution. We can speak about the range of scores. The range of scores would be the difference between the largest score and the smallest score. So we're talking about 79 minus 30, which gives us a range of 49, which is relatively wide, right? Mhm. Right. So as I said, I mean, the average score or the mean score is about 52, and we could almost say that um let's see. All right. So now that we found the mean, all right. Now that we have our list of data here, let's see exactly where the mean would fall. The mean falls just about here between 51 and 53. So the mean is about 52. And let's see how many scores are to the left of the mean and how many scores are to the right of the mean. We have 1, 2, 3, 4, 5, 6, 7, 8. Well, 9. 9 scores to the left of the mean, and it means we have 1, 2, 3, 4, 5, 6, 7, 8 scores to the right of the mean. So this more or less shows an even distribution of the scores above the mean. All right? But of course, we've seen that there are a few scores which are relatively high, 71 and 79 only two. And similarly, there are 3 scores which of course are relatively low. Failing scores, those are below 40, specifically 30, 33, and 37. All right, so that is that part of the question there, describing the distribution of the data set. Part F, it says, your friend suggested that a bar graph or histogram could be used to represent the data. Advise your friend on which graph is the better option, giving one reason to support your answer. Now, let's talk about bar graphs and histograms. Now, what do these typically have in common? They both show numerical values on, say, the vertical axis. So if we were to just do a rough little sketch, something like this, right? Perfect. What? Anyways. So typically when we draw bar graphs, of course we include bars, and we often use bar graphs to represent what we call categorical data. Categorical data in the sense that they are different categories, and these are usually qualitative data. Let's say, for instance, you are a salesperson and you're analyzing your monthly sales at the end of the year. you could probably say put the months of the year on the x-axis, so January, February, March, April. What comes after April? January, February, March, April, May, June, July, and so on. So these are not quantitative data. And typically, when drawing bar graphs would represent this. On the x-axis, we typically involve or include what we call categorical or non-quantitative, which means qualitative data. However, when we speak about histograms, on the other hand, histograms generally show quantitative data on both axes. And so, given that we're talking about scores of students, and of course, the number of students who will get certain scores, then an histogram would be more suitable for representing this type of data, right? So we're talking about strictly quantitative data. The actual scores and number of students would actually get those scores, and so an histogram would be more suitable. Also, in terms of the histogram, we could actually arrange the scores in terms of certain intervals. So, for instance, if we look at the seven-leaf diagram, we see that the scores range from 30 being the lowest to 79. And so we could basically arrange these scores in certain intervals, like say, for instance, 30 to 39, 40 to 49, 50 to 59, and then we'd have 60 to 69, and lastly, we could have 70 to 79. And we could basically plot our histogram where we have number of persons obtaining these scores on the vertical axis, and of course the respective intervals on the horizontal axis. So once again, given the fact that we're working or we're dealing with strictly numerical or quantitative data, then the histogram will be more suitable for representing this data as opposed to a bar graph. All right. So this is the end of the question, and this question was, of course, question 6 from May June 2023 edition of CSEC AdMaths.